Hello everyone. In this video we're going to run through the steps it takes to create a surface, lay out an alignment, create a profile, a finished ground profile, assembly with sub-assemblies, daylight, and then make a corridor where we can daylight to the original ground surface. So we'll just start going through the steps. The first thing I'll do is import points so that I can make a surface model. So I'll go here to the Insert tab of the ribbon, Points from File, go find a file, so here's a PENZD file. There we go, looks good. So now I have a bunch of points, and significantly I have a point group called all points. So now I want to create a surface model from these points. Create surface. Give it a name, layer, default style, all that's fine. I'll say OK. So now the surface exists, but it doesn't yet have any data in it. So I'll go down, drill down into the surface definition, right-click on point groups and add all points. Now that surface has points in it and I have surface data. I will quickly draw a polyline to use as a boundary for this. So this is just a regular AutoCAD polyline, and the idea here is to cut out these areas in here where we have this big area of interpolations that we don't want. So regular old polyline, I close it, then I go back into the surface definition, go to boundaries, add, make sure it's an outer boundary, you can name it or you don't have to, and say OK. Pick this polyline I just drew, and there I've cut off those interpolations. So the next step is to create an alignment. So alignment creation tools, what's the alignment name, etc., etc. I'll just take the defaults. Come up here, tell it my curve and spiral settings, tell it my default curve radius, and I'll just say 300 feet. And then I'll go tangent, tangent with curves. Give it my starting point. This will be a PI, another PI, and I hit enter and I'm done. That alignment now exists. Next thing I want to do is create a surface profile for that original ground surface. An easy way of doing that is to select the alignment on the screen, go up on the ribbon and find surface profile. See, it has my surface selected. I make sure I pick add. Then I can tell it to draw in a profile view. If I want to go through and pick profile view heights and what the style, etc., I'm going to keep, I'll just use the major grids style. Tell it to create profile view. And there I have that original ground profile. Next I want to create a finished ground profile. So for that I can select the profile view object and then on the ribbon pick profile creation tools. Give it a name if I want. Here again, curve settings. So my default, tell it that I'm using parabolic curves. Default length for crest and sag curves, and I want to make those 200. Okay, then tell it I want to draw tangents with curves. And we'll start up here at this, right at the existing ground. I'll do something a little crazy so we can see the vertical curves better. Okay. So there we have the finished ground profile. Now the next step then is to create an assembly So to do that, I'm on the Home tab of the ribbon. I go to Assembly, Create Assembly, and give it a name if you want, etc. Here, boom, I've created an assembly. So this line and these markers constitute the assembly. Now it's not real functional at this point because we have not yet attached sub-assemblies. So let's say I want a lane. I could use lane super elevation AOR, go up to my properties, set which side it's on, default width, slope, depths of the different import materials, etc. Outside point code, I'll just take the defaults and I'll place that lane. Maybe I want to put in curb, gutter, and sidewalk off of that. I can go to curbs, urban, curb, and gutter. Here again, I'm not going to set any defaults or any values. I just want to make sure it's going to the right side. And I'll place that up here. Okay. And then maybe a sidewalk, so urban sidewalk. Here again, check properties. It's going on the right. Okay, it'll be 5 feet wide. Good enough. Pick here. I've placed my sidewalk. Now I want to do a link to the surface so I can daylight to the surface. So I'll go here to generic, use link slope to surface, set my parameters. Right side slope, I want to be at 50%, or if I wanted, I can say 2 to 1. So either way, okay, cut and fill, good. Point code, I want it to be called daylight. Okay, top and datum come in, that's fine, and we'll have that daylight come off the edge of the sidewalk. Okay. Now, for simplicity, I'm just going to mirror these objects from the right over to the left. So I can pick those objects, those sub-assemblies, go here to the ribbon and find mirror. Do not use the AutoCAD mirror command. This is a special command that is for mirroring sub-assemblies. And then pick the assembly line, and that has been mirrored. So if I go into my assembly properties, on the construction tab, I can see I have a right side, I have a left side. So now it's time to create the corridor. So back to the Home tab of the ribbon, corridor, give it a name, okay, baseline type, in our case is going to be alignment and profile. New versions of Civil 3D allow you to create a corridor from feature line. We're not doing that in this case. The alignment we're going to use is alignment 1, profile is layout 1, and the assembly is assembly 1. The target surface is OG, and I do want it to open the corridor properties so I can set additional baseline and region parameters. Say OK. Okay, I can set frequencies. I can set targets. I definitely want to check my targets, and I see here target surface, original ground for the link slope to surface on right and left. So that's the biggest key, and say OK. So now I have created a corridor, and it is daylighting to that original ground. The next step, in order to get cross sections on the screen that are plottable, would be to go here to the Home tab of the ribbon, go to Sample Lines. I hit Enter so I get the dialog to pick this alignment. Okay, what data to include? I want to include the OG surface and the corridor. That's cool. That looks good. Okay. How do I want to collect the sample line points or stations? So I'll go here and I'll say from corridor stations. So which corridor from alignment start to alignment end? I have those both set to true. Left swath width, let's do 75. That's probably way too much, but I'm going to do it anyway. And then those sample lines have been drawn. And you can see here my widths are out there plenty far that I'll definitely see my daylighting well within those. Once those sample lines are created, now I can go ahead and create my section views. So I go on the Home tab of the ribbon, I go to Section Views, create multiple views, which alignment, which sample line group, section placement. In this case, I'll say draft. If I want to adjust how they're placed in relation to one another, I would edit the group plot style, okay, etc., etc. I'll just say create section views and there you have sections. Now, if you want to calculate earthwork volumes on this, what you would do is create a corridor surface which can be compared to the original ground surface. In order to create the corridor surface, come in here, pick any part of the corridor, and then go up on the ribbon to Corridor Surfaces. Pick this button to create a corridor surface, and then tell it the data type to use. Okay, I'm going to use the links, the datum, and I want to make sure my overhang correction is set to bottom links. Hit the little plus here. So now the datum has been added as a data source for this surface. I also want to make sure I go to Boundaries, right click on the surface name, and use the corridor extents as the outer boundary. Say OK to that, rebuild. And now I have a surface for that corridor. Okay. Once I have that surface, and I already have the original ground surface, now in order to calculate the earthworks, I would go on the Home tab under Surfaces, create a new surface. Now this is very important. The type needs to be changed from tin surface to tin volume surface. Okay, and I'll name this and I'll call it volume. Okay, my base surface will be the original ground. My comparison surface will be the finished ground, the corridor surface. Say OK. And now that surface called volume, if I look at its properties, I right click on it here on the Prospector tab, go to Surface Properties, and look at Statistics under Volume, and there are my volume numbers.